Okay, it is 2 into 2, I think. This is B here, B is 2. I'm sorry. This is 2 to the 4. So it's 3, 2, 2. 3, 2, 2. Alright. This is 2 into 2. First row. Second is 3, 2, 1. Alright. No problem now. If any mistake, calculus mistake doesn't matter. I mean, you can just judge that. I mean, just find out if there is any calculus mistake. This is just systematic. Process is systematic. If there is a mistake from my side, I'm sorry for that, but because I noted down here 2 in place of 2, I wrote down here 1. So that was a mistake from my side. I'm sorry. Now this is 2 here. Okay. Then it's okay. 2 3 are 3 3 are 3, 2 3 are 2 4. All right. 2 3 are 6 again. This is 2 3 are 6. 2 4 are 8. Last 2 4 are last row. 2 2 are 4. 0. 2 into 0 0. This is 0. Now they have to be added up. The final result of this, let me write here itself. Final result of 3a plus 2b is 15 plus 6. 15 plus 6 here corresponding elements are added up. 15 plus 6, 12 plus 4. And this is 15 plus 4. Alright. Then 6 plus, here it is 6. 6 plus 4. Then 6 plus 2. Then 9 plus 6 here. 6 plus 6 here. Then the third row, 6 plus 6, then 3 plus 8. Last row, 3 plus 4, 3 plus 0, 3 plus 0. The final result, let me write here. So 15 plus 6, 21. 12 plus 4, 16. 15 plus 4, 19. 6 plus 6, 12. 6 plus 4, 10. 6 plus 2, 8. 9 plus 6, 15. 6 plus 6, 12 here. 3 plus 8, 11. 3 plus 4, 7. 3 plus 0, 3. 3 plus 0, 3. This is the final result. This is the final answer. Type, part 3, 3a plus 2b is finally solved. This is the answer here. Okay, so in this way the process is systematic. We have to just understand what the process of this. So this is addition, multiplication of a scalar to a matrix and then added up. This is everything is now explained here. Now let me take question number 3. Question number 3, transpose here. We have to just find out that whether these two results are same. Then transpose of a plus b whole transpose a transpose plus b transpose will be proved. So let me prove this. Here question number 3 is a is equal to, if a is equal to 1 1 3, 1 is first element, 1 is second element also. This is 3 2 1 4 3 5 and b is equal to, here it is 1 2 0, then 3 0 1 4 0 and 1. Then prove that. To prove, then what we have to prove here, that a plus b whole transpose equal to a transpose plus b transpose. So first we have to find out what is a plus b, then whole transpose. Okay, then first find a transpose, then b transpose, then add them. A transpose plus b transpose, right hand side. First let me prove what is left hand side. For that a plus b is required. So let me take left hand side to prove here. This is proof of this. Let me take proof. How to prove this? Left hand side is equal to a plus b whole transpose. First find out a plus b. Let me first write the first element or first matrix A. Matrix A is 1, 1, 3, 3, 2, 1, 4, 3, 5 plus what is B matrix 1, 2, 0, 3, 0, 1, 4, 0, 1. This is B matrix. Now add them correspondingly. 1 plus 1, 1 plus 2, 3 plus 0, 3 plus 3. I could write directly, but let me just show you that systematic so that it can be added. 3 plus 3, then 2 plus 0, 1 plus 1. Corresponding elements are added up. 4 plus 4, 3 plus 0, 5 plus 1. So it is nothing but this is 1 plus 1, 2, 1 plus 2, 3, 3 plus 0, 3, and okay. So 3 plus 3, 6, 3, 2 plus 0, 2, 1 plus 1, 2, this is 4 plus 4, 8, 3 plus 0, 3, 5 plus 1, 6. Now this is A plus B. Therefore, A plus B whole transpose means transpose of this. What is transpose? We change the rows into columns. A plus B whole transpose will be equal to first row will become the column. First column. This is 2, 3, 3. First row we have changed into column. Second row is 6, 2 and 2. Then third row, third column 8, 3 and 6. This is the result of A plus B whole transpose. Let me write it here. The final result is of, let me write it here. This is A plus B whole transpose left hand side, which has given us 2, 6, 8. It is 3, 2, 3. It is 3, 2, 6. Okay, this is your left hand side here. So let me take the right hand side. For that, A transpose is required. This is your left hand side. Now I have to prove the right hand side is also the same. For that, A transpose is required. Here A is equal to, let me first write A. A is 1, 1, 3. 3, 2, 1, 4, 3, 5. Both are of same order, 3 by 3 can be transposed easily and then added up. A transpose therefore A transpose will be equal to, this is first row, first column 1, 1, 3, 3, 2, 1, 4, 3, 5. This is a transposed matrix A. And B here is, sorry, B, let me first write. B here is this 1, 2, 0, then 3, 0, 1, 4, 0, 1. Okay, this is your B. This represents B transpose is equal to B transpose. Let me find out. Because A transpose plus B transpose. We are calculating B transpose here. A transpose we have calculated here. We have just obtained here. That will be added to this B transpose. But B transpose is what? This is 1, 2, 0. First row, first column it has become. Second row will become the second column. 3, 0, 1. This is 4, 0, and 1. This is B transpose here. Therefore, A plus B transpose. Let me add them. Therefore, A transpose plus B transpose is equal to, this is A transpose here. Let me write 1, 3, 4. This is 1, 2, 3. 3, 1, 5. Plus sign. What is B transpose is this? This is 1, 3, 4. 1, 3, 4, then 2, 0, 0, 0, 1. Now let me add them. The corresponding elements are added up. Let me add them correspondingly. What the corresponding elements addition? 1 plus 1, let me write them. 1 plus 1, 3 plus 3, is 4 plus 4, 1 plus 2, 2 plus 0, 3 plus 0, 3 plus 0, 1 plus 1, 5 plus 1. And the result is 2, 3 plus 3, 6, 4 plus 4, 8, 1 plus 2, 3, 2 plus 0, 2, 3 plus 0, 3, 3 plus 0, 3, 1 plus 1, 2, 5 plus 1, 6. It is same. We check it here. 3, 2, 6, 3, 2, 6, 3, 2, 3, 3, 2, 3, 2, 6, 8. Same. This is grouped, hence A plus B whole transpose is equal to A transpose plus B transpose. Proved. It has to be proved, so we have proved it. Proved, hence proved. Okay, so this is question number 3 we have taken. Let me talk about question number 4 here. So question number 4 that we take. Okay, so question number 4 is of what kind? Let me check it. Now show that any square matrix can be expressed as the sum of two matrices, one symmetric and other symmetric. Okay, so two matrices, one symmetric. First let me find out what is A plus A transpose. So then A minus A transpose. Are these two matrices? First is symmetric matrix and other is symmetric matrix. First let me take first fourth question is, it says show that any square matrix, let me take A is a square matrix and take this is 2, 3, 1, 2, no problem. Let A is a, now we have to just show here, show that any square matrix can be expressed as the sum of two matrices. Sum of two matrices, one symmetric and other symmetric. So what is symmetric matrix? What is symmetric matrix? First let me think about that. So symmetric matrix are just find out what is A plus A transpose and A minus A transpose. These two matrices, first matrix will be symmetric matrix and other matrix will be symmetric matrix with negative numbers. Okay, so that will be obtained. So what is symmetric matrix? First let me define it. Now symmetric matrix is what? If transpose of a matrix, sorry, if A transpose equal to A, this is symmetric. This is a symmetric matrix. Okay, so a symmetric matrix is obtained if transpose of a matrix is the matrix itself, then it's known as symmetric matrix. It means if rows are changed to columns, okay, then there is no change. The matrix will be same. For example, every identity matrix is symmetric matrix. Okay, is symmetric matrix. Every identity matrix is symmetric. So A transpose equal to A. Then A is a symmetric matrix. Symmetric matrix. And if A transpose equal to minus A, then A is a symmetric matrix. Then A is a symmetric, sorry. And A is a symmetric matrix. With negative sign we have to obtain. We find A transpose and A transpose comes out to be minus A, negative of the matrix itself, then this matrix A will be known as symmetric matrix. But in this case, we have to find what is A plus A transpose. Let me just find out A plus A transpose here. This will be symmetric matrix and A minus A transpose will be skew symmetric matrix. Sorry, this minus sign. A minus A. If I find out A plus A transpose, it will be a symmetric matrix. Okay, because if I find transpose of that matrix, okay, then it will be a symmetric matrix. Just let me prove this. And A minus A transpose will be skew symmetric matrix. Well, if A minus A transpose, let me find out this matrix. A, I have taken here A as this. To prove, I am proving this. This is proof here. Let this be a taken. Let A is equal to this. 2, 3, 1, 2. Any matrix we can take is square matrix I have taken here. Okay, so that transpose will give us the same type of work, only then that can be added or subtracted. So I have taken here a square matrix. They show that any square matrix I have taken. So show that any square matrix can be expressed as the sum of two matrices, one symmetric. Now it is, if it is symmetric, and it is symmetric. So 1.2, I'll just find out 1.2 and 1.2 of this. If I add them, undoubtedly, if I add these two matrices, addition of this, sum of these two matrices, this plus this, we will get A dash will be cancelled out, or A transpose will be cancelled out. Half A plus half A is A, the matrix itself. That means they show that any square matrix can be expressed as the sum of the two matrices, one symmetric and other symmetric. First I have to find that 1/2 A plus A transpose is a symmetric matrix, and 1.2 A minus A transpose is a skew symmetric matrix. That is the point. Here A plus A, first find A transpose. Okay, so 1.2 we will write later. Let me first find what is A plus A transpose. So here A is same 2, 3, this is 1, 2, plus A transpose. A transpose is first row will become column, second row will become second column. This is 1 and 2. Now if I find the addition of these two, it will give us 2 plus 2, 3 plus 1, and 1 plus 3, this is 1 plus 3, this is 2 here. Okay, and 2 plus 2, it is giving us 4, 4, 4 here, 4 here. No problem at all. The transpose of this, if I find out, sorry, now transpose of this will give us the same matrix here. This is 2 by 2 matrix we have obtained. So what is the transpose? So A plus, because this is symmetric matrix, because if I find the transpose of this whole, the transpose of A plus A transpose, why this is symmetric matrix? Because we find here this, if I find symmetric, transpose of this whole, it will give us the same thing. 4 and 4 will become first row has become first column, 4 and 4. This is the same type. Okay, so of order 2 by 2 and symmetric matrix, it is symmetric matrix here. No problem. It is a symmetric matrix. A plus A transpose is a symmetric matrix. If I find 1.2 of this, then what is that? Therefore 1.2 A plus A transpose, okay, of whole transpose, this is symmetric matrix, will give us what? This is symmetric matrix. Yes, it is 2, 2. We have to divide each element of this matrix by 2. It will be 2, 2, 2, 2. Okay, so this is a symmetric matrix here. So we have find that this matrix was symmetric, but divided by 2. It is this first. Now let me find what is A minus A transpose. Is it skew symmetric or not? Let me check that. A minus A transpose will give us, this is A here, 2, 3, 1, 2. Transpose will give us the same thing, but this is minus sign in between answer. This is minus sign. 2, 1, 3, 2. This transpose matrix. So difference, let me find 2 minus 2. 2 minus 2 here. Okay. This 3 minus 1. 1 minus 3, 2 minus 2. Okay, it will give us first 0, then 2, this is minus 2, it is 0 here. What we see, it is if I take minus sign common here, okay, this matrix is giving us, if I take minus sign common, will it give us the same thing? It is a skew symmetric matrix. Because if I multiply this with minus sign, okay, so this minus sign will give us minus into minus, it will give us then 0, it will be then minus 2, I have to write here, okay, and this is minus 2, this is plus 2 here. The minus sign, if I take common, negative, it will be positive 2, and this is 0 here, no change. So this is the same matrix with negative sign here. 3 minus 2 is 2. But if I take this as a symmetric matrix, so I just find out 2 minus 2, 3 minus 1, 1 minus 3 is minus 2 here, okay, and this is 2 minus 2 here. So minus sign, if I take common, this is with minus sign and with negative value. So A minus A transpose is a skew symmetric matrix. So it is with negative sign, same value is obtained here. Minus sign is different. Okay, 2 and 1. Okay, this we have taken 2, 3, 2, 3, and this is 1, 2. Okay, okay, so that is there. 2, 1 and 3, 2. Okay, 2, 3, 1. All right. Difference of this A minus A transpose has given us this value. Minus sign after common, it is giving us then minus minus plus. It will be the negative sign. Okay, so this is that value. This is negative of this value. The same matrix is, oh, sorry, transpose we have to find out of this. I'm sorry. If I find transpose of this whole matrix, then that will give us, if that gives us the negative of that, I'm sorry, okay, so that symmetric matrix A plus A transpose, we found that it was symmetric matrix. Okay, now I have to prove that this is skew symmetric matrix. If I find A minus A transpose, whole transpose, it will give us minus sign with. Okay, so this is the value of this. It is to be transposed. Let me transpose this is 0 and minus 2, then 2 and 0. So I have to take minus sign common. It will give us minus sign common. If I take minus sign, we have to multiply with minus sign inside. First 0 into minus is 0. This is minus 2 here. This is plus 2. This is 0. So this is the same value. Negative of this is obtained. If I find transpose of this, transposing the difference of these two matrices is giving us a skew symmetric matrix. This matrix is A minus A transpose is a skew symmetric matrix. As we see here, the transpose of that matrix, if it gives us negative of that same matrix, A minus A transpose is obtained by with negative sign here. It is a skew symmetric matrix. Alright. Now, or if I divide it by 2, doesn't matter. Let me divide it by 2. It is if half of A minus A transpose, this will give us what? This value is, now I have to find out A minus A transpose, half of that. It is nothing but 0, this is 1, minus 1 here, this is 0. This is the value. Okay. Now if I add this with A plus A transpose, half of that, that was 2, 2, 2, because 4, 4 was coming. So therefore, a matrix, now if I add these two matrices, that is A plus A transpose, half of this, and plus half of A minus A transpose. This is skew symmetric matrix we have just proved. A minus A transpose is a skew symmetric matrix, and A plus A transpose is a symmetric matrix we have just proved. Addition of these two, the sum of one symmetric matrix, other is skew symmetric matrix. will give us this matrix itself. Let me write them. This is nothing but 0, 1. This is minus 1, 0. Sorry, this value is this. I'm sorry. Here this value was 1, 1. Sorry, 2, 2, 2. After dividing by 2, these are the value here. And plus sign. Half of this value is this. This is 0, 1, minus 1, 0. Now if I add them, 2 plus 0, 2 plus 1, 2 plus 2 minus 1, 2 plus 0. It gives us 2, 3, this is 1, 2. Is the same? Yes. 2, 3, 1, 2. 2, 3, 1. What does it mean? It means this is a matrix A is so that any square matrix can be expressed as the sum of two matrices. Two matrices, this matrix and this matrix. Now this matrix is a symmetric matrix and this matrix is skew symmetric matrix. We have just proved here. Sum of these two matrices, which is symmetric and skew symmetric. Addition of these two matrices is giving us the same matrix. This 2, 3, 1, 2, 2, 3, 1, 2. So this is matrix A. A square matrix A can be expressed as the sum of two matrices, in which one matrix is symmetric matrix, other matrix is skew symmetric matrix. So we have just found that A plus A transpose, half of that was symmetric matrix, and half of A minus A transpose is a skew symmetric matrix. Okay, so then addition of these two matrices, symmetric and symmetric, is giving us the same matrix A. We have just proved that a matrix A, which is a square matrix, can be expressed as sum of two matrices. One of them is symmetric and other is symmetric. Hence proved. This is hence it is proved. Hence proved. Okay, so this is question number 4 we have done. Let me take the next question. Okay. Now question number 5. What does question number 5 say? Let me check it. Okay, let me clean it. This is dark. Before taking question number 5, let me clean the board. Okay, now let me take question number 5. With the 5th question, the question is, okay, question number 5 says if A equal to this, B equal to this, find A, B and B at now multiplication. Okay, question number 5, if A is equal to 1, 0, 2, it is 1, 2, 1, 2, 3, 1, and B is equal to 1, 2, 3, 2, 4, 3. Now this is of order 3 by 3. First matrix is A is 3 by 3, 3 rows and 3 columns. But this is 3 by 2, 3 rows, 1, 2, 3 and 2 columns. 2 columns. Where number of columns of first is equal to number of rows of second. They are comparable. Sorry, conformable. Here solution we are finding out. Here A and B are conformable for multiplication. Let me find out A into B. Therefore, AB is equal to, let me write A first. This is 1, 0, 2. Here it is 1, 2, 1, 2, 3, 1. Now B is multiplication sign we can put in between, or just write this into this. And this is 1, 2, 3, 2, 4, 3. Okay, so therefore, let me find AB is what? Here AB, first row multiplied to first column, correspondingly you get first element. Now the order of the resultant must be 3 by 2. This number of columns equal to number of rows. So this row 3 and 3 will cancel out. 3 by 2. The order of the resultant matrix will be there. Okay, so just to obtain multiplication, first row multiplied to first column, then second column, correspondingly 1 into 1 plus sign, 0 into 3 plus 2 into 4. This is first element of mutual addition plus multiplication. Corresponding elements are multiplied, 1 into 1, 0 into 3, 2 into 4. This is first element. Now first row multiplied to second column to obtain the second element, 1 into 2, 0 into 2 plus sign, 0 into 2, this 0 into 2, 2 into 3 plus 2 into 3. This is the second element. Now second row multiplied. Second row, first column correspondingly 1 into 1 plus sign, 2 into 3 plus sign, this 1 into 4. Okay, then first second row, second column correspondingly 1 into 2 plus 2 into 2, this 2 into 2, 1 into 3 plus 1 into 3, second element. Now third row multiplied to first column, then to second column correspondingly. First column corresponding multiplication, 2 into 1 plus 3 into 3 is 3 into 3, 1 into 4 plus 1 into 4. Now again this third row, second column, it will be 2 into 2 plus